5.1 time. So in Chapter 5, we're going to talk about a bunch of things, but before we're able to get to any of those, we need to make sure we understand our properties of exponents. So in a class like Algebra 2, this should be review of what you did in Algebra 1. We're going to talk about multiplying with exponents, powers of powers, all that good stuff. So the first rule we're going to see is the product of powers. This is just saying if you have the same base raised to two different powers, you can add those two powers together, and here is why. You don't have to do this every time, but if you want to do x squared times x to the fifth, x squared is just x times x. X to the fifth is just x times x times x times x times x. It would be silly to do this over and over because we can just count how many x's do we have. Well, we have 2 plus 5 of them, or 7 of them, so that's just x to the 7th. So you can do this very, very quickly. Y cubed plus y to the 4th plus y squared. Just add those exponents up, so that would be y to the 3 plus 4 plus 2 is 9th power. If you have two different bases, you cannot combine those two. You can only combine things with like bases. Also, if you don't have an exponent written, that is just the power of 1. So x to the 1st times x to the 6th is x to the 7th, and then y squared just hangs on along for the ride. Can't do anything with that. If you have a power of a power, you would multiply those powers. Once again, I will show you why. If you have x squared cubed, what that is that's x squared times itself 3 times. And at that point, you're just right back to where we were here. So this is x squared times x squared times x squared. That's just x to the 6th. 2 times 3 is 6. So if you have 5 to the 4th squared, that is the same thing as 5 to the 8th power, which we could put that into a calculator, but for our purposes today, I'm cool with us just leaving it as 5 to the 8th. That's going to be a pretty big number. Next rule is, what if you have two things being multiplied or multiple things being multiplied and all of them raised to a power? Well, in that case, you can bring that exponent to both pieces. You can almost think of it like distributing. Technically, you're not distributing, but you are taking a to the mth power times b to the mth power. So if you have xy quantity cubed, that is the same thing as x cubed y cubed. 2x to the 4th is going to be 2 to the 4th, x to the 4th. If you want to simplify 2 to the 4th, that is 16, x to the 4th. It's 16 because 2 times 2 times 2 times 2. Did I say that the correct amount of times? It's 16. Negative 2w squared is negative 2 squared times w squared. I like to put the parentheses there because we know that's just going to be 4w squared. If the negative is not in the parentheses, the negative is not being squared, so the negative hangs on for the ride. Negative 2 squared, w squared, or negative 4w squared. So be very careful where your negative is. If it's in your parentheses, you will square it, or cube it, or to the 4th it. Any negative number to an even power is always going to be a positive number because you'd be having a negative 4 4 times. I'll show you what this would look like. And what ends up happening is you take negative 4 times negative 4, that's 16, times negative 4 times negative 4, that's also 16. All of a sudden you have a positive number, 256 for what it's worth. Negative 4 to the 5th power, though, is going to be a negative value. You would take negative 256 times negative 4, basically, at that point. And you would have negative, what, 1032? That's bad math, 24. Jeez. Negative 1024. So a negative number to an odd exponent is always going to be negative. Negative number to an even exponent will always be positive. Here are some to try on your own. I will let you pause the video if you want to try them. Otherwise, I'm going to go through them very, very quickly before we look at a couple more things. This would be 4 cubed x to the 6th y cubed. You could simplify 4 cubed. That's just going to be 64. Negative y cubed times negative y to the 4th times negative y to the 5th is going to be negative y to all of the stuff added together. So that would be 912. That just simplifies to y to the 12th. If you have a negative raised to an even power, you can basically just dump the negative. Here you got two different parts. You would have x to the 6th times y to the 12th times x. Then we'll combine. That's just x to the 1st. So you would have x to the 7th, y to the 12th. In here, you're going to bring that 3 in everywhere. So that's negative 3 cubed x cubed y to the 6th. That would be a negative 27 x cubed y to the 6th. Here we got a lot going on. You basically have the same expression right here as we did here. So this is negative 27 x cubed y to the 6th. We just did it. Times negative 2 squared is 4 times x to the 4th times y squared. And then we would simplify all of this. So we're going to multiply our like pieces. So 4 times negative 27 is negative 108. X cubed times x to the 4th is x to the 7th. Y to the 6th times y squared is y to the 8th. Finally here, you could bring the 2 in both pieces or simplify first. Does not matter. I'll simplify inside first. X times x cubed is just x to the 4th. So this becomes 4x times x to the 8th, which is just 4x to the 9th. Super fun, huh? All right, let's get to the good stuff. Negative exponents. When you have a negative exponent, what you are doing is you're essentially bringing it to the other side of the fraction. So if you don't believe me in your calculator right now, if you take 2 to the power of negative 2, you're going to get 0.25. Because what you're doing is you're doing 1 over 2 to the positive power of 2, which is 1/4. So here, if you have 5a to the power of negative 2, you would basically just say this is just 1 over 5a squared, and then could simplify as 1 over 25a squared. You only move the things with the negative exponent. So in this case, the 9's going to stay on bottom. The x part's got to move up, and the y part has to move up. You could do y to the 1st power or not write anything. The 9 doesn't move because the 9 doesn't have a negative exponent acting on it. If you have something to the power of negative 1, that's actually really easy. All you do is you just flip everything. So you would have 2x to the power of negative 1 over negative 4x squared, and then we're going to clean up from there. You have to bring an x down, so that would be 2 over negative 4. You'd have another x down here, so that would be x to the 3rd power. So that is 1 over 2x cubed. For this one, you would have 1 over 5 times 1 over 0. Are you allowed to divide by 0? Well, I think we should probably know by now that is not going to be something that we're able to do. So this would just be undefined or impossible. Whoa. That was crazy. Undefined. So you never want to leave an answer with a negative exponent. So I already did a little bit of it here, but I just want to quickly go over the division property for exponents. For the division property, because you have, in this case, 5x's on top, and you have 3 on bottom, what ends up happening is you have things cancel out or simplify to 1. So like x divided by x is 1, x divided by x is 1, x divided by x is just 1. So your end result, when you're dividing, in this case, is just going to be x squared. The way we can do that faster is you can subtract the exponents from the numerator and denominator. So if you're dividing, you can subtract your exponents. So in this case, this would be x to the negative 2nd minus negative 8th, which is x to the 6th power. What you could also do is you could bring x to the 8th power up, x squared down, and then 2 would simplify out. So you'd be left with x to the 6th. So one little quick thing to note is any number raised to the 0th power is always 1. So if you take 100 to the 0th power, that's 1. If you take negative 22 to the 0th power, that's also 1. The reason this works is illustrated like this. If I have x cubed over x cubed, you would agree, I hope, that something divided by itself is equal to 1. But using the quotient property, we could also do this, x to the power of 3 minus 3. But that's just x to the 0th power. So all of these are equal. So we can say this is 1. So then this would have to be 1. So anything raised to the 0th power is just 1. Last piece we're going to look at today is scientific notation. This is something you no doubt have done in, you got it, a science class. Scientific notation is just a way for us to express really big numbers or really small numbers in a way that's concise without a bunch of zeros. Scientific notation looks like some number between 1 and 10 times 10 to some power. So if we want to do operations with scientific notation, since you're multiplying, what you're saying when you're doing 2.4 times 10 to the third times 3.1 times 10 to the fourth is you are saying 2.4 times 10 to the third times 3.1 times 10 to the fourth. Now, as far as multiplication goes, you can multiply in any order. So what I'm going to do is I'm going to take 2.4 times 3.1, and I'm going to use a calculator to do this. 2.4 times 3.1. I get 7.44. And now that's going to be multiplied times 10 to the power of, well, you have 10 to the third, 10 to the fourth, that would be 10 to the seventh. Let's look at this next one. For this next one, we have 5.4 times 10 to the third times 3.1 times 10 to the sixth. When we take 5.4 times 3.1, you're going to get 16.74. And then you're going to have that times 10 to the power of 3 plus 6 is 9. Now this would seem like this is okay to leave your answer like this, but actually scientific notation, your number times 10 to the power has to be between 1 and 10. Bigger than 1, or at least 1, and less than 10. So 16 is too big. What we end up needing to do is move the decimal place over. So what we're doing is we're essentially going to steal a 10 from there, and then we're going to tack on an extra 10 to our final result. Because basically if we were to take the 10 from here, that would move the decimal over 1 to get to that 16.74. You can try this last one on your own if you want to pause the video, but I will just burn through it right now. We take 1.2 times 3.6. We get 4.32. Then we would have times 10 to the power of negative 3 plus 4 is just to the power of 1. So realistically, this would be kind of a silly one to do in scientific notation. You could probably just say it's 43.2. But if you wanted to give your answer in scientific notation, there you are. So that does wrap us up for 5.1. A lot of properties today. It's a lot of just simplifying, simplifying, simplifying. So hopefully you'll get good practice in the homework on all that.